Welcome back, EHS 300, and in this video we're going to focus on drinking water purification, and we're also going to recap MCLs, or maximum contaminant levels. So we're going to go through this whole process in this section from intake all the way to distribution in the tap. But for now we got to really quickly recap maximum contaminant levels. So we're going to first talk about where MCLs are set. So MCLs are set by the US EPA for organics, inorganics, microorganisms, turbidity, and radionuclides. Some examples are things like benzene and trichloroethylene and carbon tetrachloride, and they can have really low standards, like in terms of low concentrations can elicit harmful effects like 5 parts per billion or 0.005 parts per million of TCE, and these things are associated with cancer. Disinfection byproducts like trihalomethanes are associated with cancer. Toluene is associated with kidney, nervous system, liver, and circulatory problems. So they have different levels and limits for a lot of things, and these levels may have changed since I made that slide, so we'll look at that here in a second. Metals. And not just metals, inorganics in general. There are standards for all of them. Some of them don't necessarily have MCLs, but they have action value levels. Things like lead and copper have been under a lot of scrutiny since Flint, Michigan, on what's an acceptable amount to be in the water and whether or not action alone is enough, or would it be better to actually have standards in place that are associated with acute MCL violations. So MCLs, they can be set for a variety of things, like we already said. So we mentioned microorganisms. They're one thing. So total coliforms and fecal coliforms. So a lot of those tests that are done are presence-absence tests. No more than 5% of the samples can be positive for coliforms in a month. Water systems that collect fewer than 40 can't have more than 1. And the reason why is if you have 2 out of 40, you would be at, what, 5%. If you had 2 out of 39, you would exceed 5%. Also, if you have 2 consecutive total coliform positive samples, and 1 is positive for either E. coli or fecal coliforms, it's an acute MCL violation. And they would want to do a boil water advisory immediately. I'm going to back out of the slides to let you see the EPA's work on this. So if you were to do a Google search on EPA drinking water standards, you will get to the drinking water rules for EPA. It tells you that they set standards on 90 different contaminants in drinking water, or sets legal limits. You can then pick through these different ones, like microorganisms. You can see things like total coliforms and E. coli are right here. And here it says, E. coli is not a health threat itself, but useful for indicating. It tells us what the standard is. The goal is 0, none. But the standard is 5%. 5% is the MCL or treatment technique. What does 5% mean? And then you have to click on the footnote. So click on the 4. Here's what it says. No more than 5% of the samples can be total coliform positive in a month. Every sample that has a TC positive sample must be analyzed for fecal coliforms or E. coli, which is typically done with the IDEX method. And 1 is also positive for E. coli, then the system has an acute MCL violation. So every sample has to have a total coliform. Every sample that has a total coliform test done has to be analyzed for fecal coliforms or E. coli. And in the event that you've got 2 consecutive total coliform positive samples and 1 happens to have E. coli in it, even just one, it's a failure. So we don't want to ever see an E. coli in our water. And if you do, you want to put a boil water advisory in place ASAP if you're a plant operator. All right, so hopefully that makes sense. No E. coli is our goal. And never do we want to see more than 2 consecutive total coliform samples as well. All right, back to the actual PDF or video. Here we go. MCLs are set for things like viruses and Giardia and Cryptosporidium. We want to reduce our turbidity a lot. Cryptosporidium was associated with the largest waterborne disease outbreak ever in Milwaukee. Analytical tests for crypto are hard, so EPA relies mostly on turbidity testing to ensure removal. Those standards that we were just looking at say that turbidity should never exceed 1.0 NTUs, or nephelometric turbidity units. 95% of the samples have to be below 0.3. And there are other standards that are out there. We're going to quickly look at disinfection standards here real quick on the EPA document. All right. Scroll up, all the way up past all those chemicals. Disinfectants. Now, states may have their own standards as well, but the EPA standard says you can treat with chloramines, and they should never exceed 4.0 milligrams per liter. Chlorine, it should never exceed 4.0. You use chlorine dioxide, never above 0.8. You can click on the 1, and these aren't maximum contaminant level goals. These are maximum residual disinfectant level goals, because they don't call chlorine a contaminant. They call it a residual disinfectant. The level of a drinking water disinfectant in which it's kept below the level where there's expected health risk. So that's our goal. All right, that's the goal. The MRDL is the actual maximum amount allowed. So and both those are 4 for the treatment technique that we use here in Richmond, Kentucky. All right, so getting into water treatment. I'm going to have you guys watch Barry's water treatment plant tour to help you get some understanding. And then we're going to go through these one by one here as we go. I think what I'm also going to do right now is just take you to the Richmond water plant using Google Maps. It's important for us to know where our water comes from. So our water in Richmond, Kentucky comes from the Kentucky River, and it comes from the Kentucky River downstream of Irvine, Kentucky. And what goes into the wastewater in Irvine ends up in the Kentucky River after it's been treated. And then that water is in the Kentucky River, and then it's treated for our consumption. Our wastewater goes into Otter Creek, which flows into the Kentucky River, and one of Lexington's intakes pulls water from the Kentucky River. So we're going to look at the Kentucky River here in these videos. I'm going to pull up some slides here, or not slides, but the Google image really quick. Okay, so I have pulled up a Google map of Richmond, Kentucky from a distance. You can see to the east is Waco, Kentucky, and then here's Irvine. To the north would be Lexington, to the south would be Berea. And if we were to leave EKU's campus and head to the Eastern Bypass and take Kentucky Highway 52 towards Irvine, Kentucky, heading to the east-southeast, we would get to a stoplight out past the Bluegrass Army Depot, which is all out here. So you can see the Bluegrass Army Depot. I might be breaking the laws here, but you can see all these huts where all the chemical weapons are stored. But anyways, if you were to head past the Bluegrass Army Depot and keep heading to Waco and turn north on this particular road And that road may be called 977, but it may be called Bend Road. And you head all the way to this town of College Hill, and it's not really a town. There's a church right there on the corner. Take Bend Road. This is the road that the water plant's on. And you keep heading on Bend Road, and then there is a drive that takes you down to the water plant. And here is the drive right here. And there's a bunch of beagle pups that live here on this corner. And this would take you into the actual Richmond water plant. And usually there's a bunch of dogs barking at you. Alright, and now if we were to go here, then I'm going to zoom out. Alright, so here I've zoomed out. So if we were to turn down that road, here's all the dogs. As we enter the water plant, we would see over to our left these ponds that exist for the kind of the extra water that leaves the water plant after they've filtered it. They have to take that and put it out here. I'll talk more about the sludge and the sludge drying beds here in a minute. Alright, so we would continue past those. There's a structure here that's the house that exists for people to stay in the event that there is a long-term emergency and people have to physically stay on the property to ensure that water is able to continue to be provided. You can see from up here, you're up on top of a big hill. It's in a bend in the Kentucky River, so the Kentucky River is down there. So that's the Kentucky River off in the distance here. You could follow it all the way to Irvine, Kentucky, and spin around. And the Kentucky River, it's dammed up, and the water here at the actual water plant in the Kentucky River is deeper in this section of river as we get close to this dam. This is one of the dams or locks on the Kentucky River. So that makes the water deeper. It's very pretty down there, actually. And here is where the water is taken in at the actual river, that spot. There's a underground pipe here down underneath the river that sucks the water in, and it goes into a building, and then that building pumps the water up the hill. You can drive down there with this road, but it pumps the water up this steep hill to the water plant. And as it comes in, the first place it goes is into these right here, where they add a little bit of chlorine, not much, to prevent the growth of biofilms. And then they also add alum or aluminum polyvinyl to start the flocculation and coagulation process to make the sediment fall out. It goes from there, from where they make the sediment start falling out, it forms floc. After it leaves the flocculation basins, it goes into these slower areas where it does sedimentation. After sedimentation, the water then ends up finding its way into the water plant. It will then travel into the water plant from these sedimentation basins into the water plant, where they'll then do filtration, and then they'll also do disinfection of the water. Sludge will drop out during this process here, and they'll also gather sludge on the top of their filters. The sludge from the bottom of here is vacuumed out by machines automatically, and it's also let go through backwashing. That sludge water will go out to these different ponds where it is dried, and then they can land apply it. And then the water that filters out of here can actually go back to the Kentucky River through a Clean Water Act permit, where they're able to discharge it. So that's just a little bit on it. And then they send water from here, and there's some underground storage, and then there are some big water towers that are out there along this road. I think there's a water tower not far from this corner. So there are several big water towers. And then on campus, near campus, there are a few big water towers that store the water to provide water pressure to the Richmond community. So that's just a little bit on the Richmond water plant and those MCLs. I'm going to make some other videos as we discuss the process more fully here in a few seconds.